Welcome to the Prosthetics and Orthotics podcast with Brent Wright and Joris Peels. Today, we're going to be doing this podcast. So why are we doing a Prosthetics and Orthotics podcast? That's really the question. Well, we're doing it because today is a really, really exciting time. We're talking about the digitization of prosthetics and orthotics. What does that mean for patients, for practitioners, for companies? And you know what? We don't know. We literally don't know. We don't know if every practice is going to have a 3D printer and a 3D scanner, or if only some will have them, or if they'll only be used for some devices, or if it's going to change the market completely with companies centralizing the production or producing these things overseas now because there's a digital supply chain. You can make them in India or something. We have no idea. And that means it's a very exciting time for us to look at this. And we're both very curious people. So I'm a 3D printing consultant. I've been working in 3D printing for about 14 years. I've done a few things. I've developed some materials for prosthetics, orthotics, and we've done some little projects here and there. But basically, I know absolutely nothing about the subject because what I do know is kind of from the material side. So I know quite a bit about additive manufacturing, 3D printing. And I think it could be applied well to this area, but I'm not entirely sure. So that's my angle, kind of. I'm kind of the kind of like, I'm going to ask questions, hopefully. And the person who knows a lot more about this subject is Brent. He's a certified orthotist and prosthetist, and he actually helps people with these digitization of this kind of thing. So tell us a little bit more about yourself, Brent. Hi, by the way.
Hey, yeah. Hi, Joris. And that's super interesting. I would say that and this is why I'm so excited about this, is we kind of flip-flop, right? You may not know a lot about the orthotic and prosthetic field, which I've been in it for quite a while now, but I don't know much about the additive field, and I think one of the things is I don't know what I don't know, but I'm curious. And there's so many technologies out there that may benefit not only the field, but clinicians, workflow. It's a game-changing time. And just for the short amount of time that I've been in this additive space, I can tell you that patients really seem to benefit comfort-wise and long-term-wise wearing these additively manufactured devices. And so I'm excited about diving into all technologies when it comes to the prosthetic and orthotic field. A little bit about myself. I started off in the field as a technician. So typically what happens is that you get some experience in the field, you make the devices, you pour a lot of plaster molds, you get dirty around the lab, you grind things, you cut things down, and then you hand them over to a clinician. So that's the way I started. Then I went to school to be a clinician. And then now 15, 20 years later, here I am playing in the additive manufacturing side, which I never thought I would be in because really I was anti-technology. And so this is kind of a little bit of an irony in being a part of this podcast, right? Because if you would have said, hey, Brent, we're going to be doing this podcast in 6 years and you're going to be talking about additive manufacturing, I would say that you were out of your mind. There's no way that I would ever consider digitizing anything in my practice, but I'm okay being wrong. And like I said, I think there's definitely a big benefit to being curious, really for the patient's sake. And just putting my clinical bias and everything else aside and, hey, what is best for the patient? So that's me in a nutshell.
So I think what's exciting about this is that if we look at additive, it's not only additive, right? So it's 3D scanning to obtain hopefully maybe more accurate fittings, which may reduce the need for fittings, may make it easier. But 3D scanning isn't that easy. You need software to repair the files. It doesn't always work. It doesn't always work really well. Repairing the files sometimes is more complicated than designing the thing from scratch. If you look at just measuring or molding, it's faster and it's cheaper in some cases as well. But hey, you can acquire the file digitally. It's supposedly more accurate. Maybe it's faster. And then you can send it to people, or you can keep it so the guy doesn't have to come back again. Or you could maybe even skip a part in the molding process or something like that. So these are kind of things that are very exciting of the scanning. And this is CAD, right? So maybe the future generations of orthotists and prosthetists will learn CAD or master CAD or be necessary. Or maybe we'll see like really easy customization software. That's like a touch of a button. You don't have to learn CAD, whatever. We'll just make an intelligent tool that turns that scan into a device. Then we've got new materials which are being introduced, new 3D printing processes as well. What Brent mentioned as well, the entire workflow. How does it work? And also the value chain, right? Who's going to be measuring? Is there going to be a certain different person measuring than making it now? Are we going to separate those two tasks? Are we going to be doing a lot of stuff still by hand? And then a lot of stuff is going to be made through milling, for example. Because that's also, I mean, it doesn't necessarily all have to be 3D printing. I mean, certain things, certain liners and things make a lot more sense in different materials. So we kind of already think that it's going to be kind of a blended thing. You know, we kind of think 3D printing is going to be kind of successful, I think. That's kind of our bet. Kind of successful, but we don't know where, right?
Yeah, I think blend is the right term because, and this is some of the stuff that I want to dive into in the podcast, is when does it make sense to traditionally fabricate and when does it make sense to 3D print or mill or what have you? And a lot of that revolves around the cost to produce a device. So for instance, I'm 5'11", and so my knee center to my foot is probably roughly around 19 inches. And then I wear a size 12 shoe, US, so which translates into like 29, 30 centimeters long. So you try to get that into a 3D printer, it takes up the whole space. And to press play on that 3D printer is expensive. So is it worth it for me to print a brace, a full brace, or is it worth it to break it down and make it modular? Is it worth it to carve it and traditionally fabricate it via vacuum forming? Those are all things that are interesting to explore to me, because you would think that just 3D printing everything would make sense. And to some point, it does. Like when we're looking at our practice, is it worth stopping everything and moving out of the digital realm to produce it? Or do we keep the cog moving? Yes, we might lose a little bit of money on it, but we've got the flow going. We're not stopping the flow. And so I think that's going to be the interesting kind of conundrum as people look at workflow is, can we go fully digital, or how do we make sure that we don't trip over ourselves when we have to split off just due to the basic idea of we're not going to make money on this device? I think it's interesting.
And there's some parallels as well. Like, for example, the closest one I think is dental, because in dental, you have an individual practitioner who sees patients and makes unique devices or measures or makes unique devices depending on what kind of dentist they are and where. And what we've seen there is that digital scanning, either through CT or other kind of intraoral scanners have become quite commonplace. Practices have taken up 3D printing now, as well as labs. And there's been centralized labs, depending on the application as well, that have been formed. And also companies that have swept out of nowhere to print millions of bridges and crowns. And other companies they used to sell a device, and now they, for example, sell the printers. So there's a lot of disruption in the business of it as well. And if you look at Invisalign, that's the other dental success, where they print about 250,000 thermoforming inserts to make Invisalign possible a day. That's a huge volume. And that's just a new company that came into that market and that did something that a lot of people didn't think was possible. So that's also something we could be seeing in this area as well.
I really like the parallel to dentistry too, because I see the value of a clinician in that they provide the clinical wherewithal to provide the final case. So like if you have a cracked tooth and you need to have a crown put on it, the dentist doesn't sit there making the crown. They identify that, hey, you have to have a crown put on. They prep it. Somebody else actually scans it typically, and they will specify, hey, this is what the material I want out of it. This is the shape. This is the intent that I have for the crown, but they don't actually make it. But then they roll back in, they take the crown after it's fabricated and place it using the skill that they've learned, and then they're on to the next patient. And I believe that in many ways, prosthetists and orthotists may need to start shifting their mind to think more like dentists and use their time super efficient, because they're the only ones that can evaluate. They're the only ones that can measure and specify, and they're the only ones that can fit. But there's plenty of other people that can fabricate. So I think it's a great parallel, Joris.
We don't know if this is going to be successful. We don't know if this is going to even it track in the future. But I think it's somewhere to start at least. We shouldn't say that like 100% will happen. What's really exciting is that now there's for dental offices, there's like complete packages. Like there's the software, the scanner, the printer, the material, and they say, hey, here you go, boom, buy this one thing and you're off. Right. So now actually a lot of these guys, crowns not, but they're making a lot of maybe molds and polymer parts and stuff like that at the dental office or at the lab now with digital. So that's actually a huge disruption in that market. What we're also seeing is that these guys are, just like you're saying, they're getting divorced from this making. So in other dental areas, we're seeing that a company that used to make is now only kind of like a scan originator, if you will. You know, they're actually outsourcing everything on the back end, and they're not actually making anything anymore because that's too expensive where they are. 3D printing is most successful in this dental thing where we make tens of millions of parts, or hearing aids where we make tens of millions of parts. We disrupted that market, which is just milling and people desk side making these parts. We disrupted that very quickly within maybe 3 years or something like that. We took over most of this in the ear hearing aid market. So there you're seeing patient-specific or geometry-specific parts that are relatively small, that are made desk side, and that are just like wholesale being replaced by 3D printers, where actually the same guys there that used to be milling it, but now there's maybe fewer of them, or the company's more efficient, or what he's doing is more low cost. So that's another way of like that we've seen in hearing aids where the person used to mill the things desk side and now they use printers. Then in that example, they also use the software. They orient the part on the software. They do exactly all of the fitting plus making jobs apart from the scanning, which is done by in the hearing aid store, let's say. So that's another parallel, I think, where we're getting, patient-specific stuff that's really successful for us. And there's a lot of things that 3D printing can't do. Well, I think that's really important that you mentioned that, Brent. The whole part about that, the foot, my favorite one is a foot. There was like a really big company that all of a sudden said they were going to 3D print 1 million shoes or something like that. And I very easily looked at the spec sheet and found out most large men's shoe sizes would not fit in their printer. And I was like, well, how is this going to work? So I think this kind of thing, this hybrid and blended thing that we could see success in some areas and completely non-penetrating other areas, I think that could totally happen as well.
Speaking of the hearing aids, and I don't want to go down a big rabbit hole, but are they actually printing the hearing aid, or are they printing the mold for the hearing aid, or is it a combination of both?
No, what they're doing is they're printing the hearing aid shell using vat polymerization, which is also called SLA or also DLP. They're actually competing technologies, but typically a company evaluating both of those things it depends. If they're used to building things on the factory floor, they'll like larger, more productive SLA machines more, big machines with light on top. If they're used to doing things desk side, the more compact, perhaps higher resolution DLP machine will appear to them most. It depends on their workflow, their volume, and the type of people they already have. And typically they will directly print a compliant material. Then it has to be printed, it has to be removed from the build platform and flashed. It's UV hardened and washed as well. And then what they do is, the step before that is they orient it in the software to make sure that the scan, which is taken at the hearing aid place, right, which is either a scan of a wax mold or a scan of a direct scan with an intraoral kind of scanner, but then like one for your ear. That scan goes to them. They orient it to make sure that it all kind of fits inside. They print the shell then based upon that together with a whole bunch of other shells. And they then have the shell, once it's post-processed, so once it's removed from the build platform and flashed and washed, they then actually literally physically put the electronics of the hearing aid inside of it and snap it shut. And that's essentially what it is. And this is only ITE hearing aids. So it's in-the-ear hearing aids. So it's the ones that are kind of hidden-ish, where if you're talking to somebody you probably don't know, there's no like big outside part or anything, but it's just like this little kind of like it kind of covers the inside of your ear. And we print the vast majority of those in-the-ear hearing aids. So if you know someone that has one of those, then nearly all of them are made with additive. And all of the companies adopted it as well. So that was really interesting to see that, or not all, but it wasn't just one company. Like in the Invisalign example, Invisalign took a long time for people to follow them. And the hearing aid example, quite quickly, all of the major hearing aid companies like Phonak and Siemens and Siaki and stuff we're doing this, So that's a really big success story. But there's tons of stuff we suck at, right? We suck at big parts. We suck at smooth parts. This kind of in the body compliance stuff is actually really problematic because of the photo initiator in the material and also the resin itself. And the handling is also quite problematic as well because it's there's the SLA materials, the DLP materials are a skin sensitization agent. So this is one of our unmitigated successes, but if you look deeper, it's not exactly an unmitigated success. So it's like we tend to get overhyped, but
right.
and we're doing more real things than people maybe think, but it's also really tiny kind of cottage industry kind of thing, I think.
Yeah. Yeah. Speaking of the hype side of things, I mean, what have you seen? And I can share a little bit around the prosthetic industry, around the hype. Like for me, it wasn't until 2018 with some of the newer materials and then HP released the multi-jet fusion stuff that I feel like materials actually made sense for sending patients out long term on a device. But before that, I feel like our field, the prosthetic and orthotic field, really wanted 3D printing of some sort, but we're playing around in the FDM world with like desktop, very inexpensive printers and failed. And it kind of flipped the switch or dimmed the switch for our whole field and maybe cooled the hype for the people in the field. And so to me, it's been a little bit hard to turn the tide and start thawing that coolness to get moving. But one of the things that I've seen is, hey, if you post case studies, videos, and things like that of patients' lives actually being changed by some of this technology, that's where the rubber meets the road. That's where people perk up and listen. So I'm just curious, like, what your feeling is from an outsider not knowing our field, and that might be a little bit of surprising to you with the history that I just shared for why people are not adopting the technology as fast as maybe.
So there's very little entrepreneurial zeal by people, startups or people outside the industry to approach this industry. There's very little knowledge about how large the industry is. And if you're talking materials companies, they'll look at dental, they'll look at hearing aid, they'll look at automotive, and then all of a sudden they don't reach this, right? So it's just not top of mind for the materials vendors or the 3D printers. And there's no startups that say, hey, we're going to be doing exactly this. There's like a dozen startups that do like this complete materials printer software package for dental. There's not a single one that does it for orthotics, right? So that's kind of like it's not top of mind, right? The other thing is that flexible materials, like you rightly say, like TPU, there's been new TPUs on powder bed fusion. MJF has a polypropylene material that's inexpensive and very high performing. But this is fairly recent. It's really difficult to 3D print materials that stay flexible and stay kind of coherent for a very long time. It's a problem for us. So and flexibility is something you do need it around the socket or around making things fit and stuff like that. So that was a major limitation. And also, I think when the 3D printing hype was at the biggest, 80% of printers or 80% of prints failed. And if you're trying to do this for a business and you've got a patient waiting for something, or Mary is going to come in tomorrow and then she wants something from you, that doesn't work. Now, we're seeing a point where even inexpensive printers, most prints, once the thing is calibrated properly, most prints succeed. So on the desktop printers, a lot has changed, but a lot of the parts you guys need are actually quite large. If you're looking at a socket or a larger part, and also these feet type parts are actually quite large for us. So that makes it more expensive. It limits the number of devices and it pushes the device cost up. Recent developments at HP MGF and also the TPUs and powder bed fusion are also, taking time to percolate through the industry, because then you're talking about you're talking about $700,000 printer, and that's a bit more investment than most people can take on. So those are the general things we're seeing, that there's just not a lot of entrepreneurial activity on this field. There's not a lot of people outside saying, yes, this is my startup. Like we're seeing people that are like now doing essentially variations on Invisalign, right? So this is a success. This is huge. It's a multi-billion-dollar company, and there's several other multi-billion-dollar companies that are just copying it essentially. And only now are people doing this. Right? Only now we're seeing a Zenium, which is like an Invisalign, but then for Southeast Asia, right? Or we're seeing ones just for China, and that's actually a really recent thing. So there's going to be a delay before we see this kind of enabling entrepreneurial activity where people say, "Hey, I'm going to arm the orthotist and prosthetist with a toolkit or a software thing or something that's really specific for them."
Did you say arm? Was that pun
Yeah.
intended?
No, I'm sorry. No.
There you go, Joris.
I
Funny
wanted to.
guy.
No. We can't do this. We can't. We seriously can't. I was thinking about why do prosthetics cost an arm and a leg, but no, I can't. We can't do this. We can't. This is a serious podcast, Brent. This is like serious.
Oh, okay.
Let's
Let's bring it back together.
I
then.
did not do that intentionally at all. Anyway, so yeah, those are the things that are really retarding the growth of the adoption. And of course, like people that like to do stuff with their hands, right? They're experiential learners, or they're people that like to work with their hands. Sometimes don't take well to being removed from the making process by a software thing. And also, we can't forget that it takes about 2,000 hours to learn CAD, right? So a lot of people, if you don't learn CAD, you can't just casually pick up CAD. You know, you can't just do it, and you can't just get started out of nowhere with it. And not a lot of people realize that you can just hire people to do it, sometimes quite inexpensively. But CAD is the real block that stops adoption. So somebody might be interested. They've never learned CAD in college or whatever, then they can't just adopt it. It's just impossible without hiring extra people. And that's also really keeps people from trying it out.
Right. Just speaking of the CAD side of things, on my journey, dealing with some of these organic shapes, you just can't bring it into, say, a SolidWorks or whatever and do your offsets or what have you, because in SolidWorks, you need to have step files or something that you can work with to thicken and that sort of thing. And I know the softwares are getting better, but I think in the same sense, like people that know CAD may not know how to marry the organic shapes with the dimension shapes to get something out that will print. So that's been some of my struggle just on my journey. But what do you, and I know you're more connected into the CAD space, and people that are really good at surfacing are actually really good at this kind of work, but just kind of curious on your input on that idea of
CAD. Horrible. It's just horrible. So on the one hand, CAD is too difficult, and also it kind of locks you into a package. So an early choice for SolidWorks will probably, condemn you to working with SolidWorks forever and working with SolidWorks-based businesses. The switching cost is very high. The packages themselves are difficult to learn, and they're difficult to work with, and yeah, especially for organic shapes, and especially for like maybe people who haven't 3D scanned don't know this, but you end up getting like an almost perfect scan, and then like there are holes in it, right? There are parts that are solved. Now, if you've ever worked with like an Artec Ava or the expensive Artec scanners, you can see that in a future it will be possible to have like kind of like a better scanning process, if you will. So where it actually will highlight while you're scanning where you've been and where you haven't been, and do this in a correct way. With these really high-end Artec machines, we're seeing that. So that's on the scanning front. We're expecting that to improve. On the CAD front, nobody's really making super simple CAD software. So I don't see that improving much. And then on the resurfacing front, there's Magix does this, GeoMagic, whatever. There's a ton of like packages that do this resurfacing. That's quite a difficult challenge, because you change the geometry, right? In some way, you're kind of painting over existing geometry and painting over air, right? So that's a bit problematic in the sense that it's always going to be, what is your sampling size? How do you resurface this thing? What algorithm do you use? And what do you end up with? Is it going to be thicker? Is it going to be thinner? But that's essentially a math problem, right? And as the machines get better at math, then we would expect that to get better. So, I think to everyone I say, can we just outsource this? Can't we just send these files to somebody and then send it back? You don't have to master any of this stuff, necessarily.
So do you feel like in the short term, as like these math problems, and I like the way that you put that, it really, that's what it is. It's math in space, and you manipulate, and it's all you do is manipulate a math problem, but you can see the change kind of graphically. But in the short term, that's kind of the answer, is more heavy duty CAD, like specialized users on the front end. And then as the workflows or processes get better, then, somebody may swoop in, like a Invisalign type of thing where some of this stuff can be automated.
I don't know. This is I evaluate CAD software and stuff, and it's really weird because I don't know CAD. But the reason is I thought very early on that somebody's going to make like a CAD, but then the WordPress of CAD, So,
Right.
and I was
Okay.
like, I'm not going to learn HTML, right? I'm not that,
Right.
I don't want to
Right.
learn
Right.
HTML before somebody, or Dreamweaver before somebody comes up with WordPress, And what we want is Twitter, right? We want to make
Yeah.
design as
160
easy as,
characters.
yeah, exactly, as
Yeah.
easy as typing. And so we're very far away from that if we compare it to blogging, which is a much easier challenge to solve, just typing stuff on the internet, and everyone can type already. That took quite a while, right? So we're talking the '90s until like these blogging tools came out in the aughts, right? It took quite a while and quite a frothy investment climate as well for everyone to blog, which ended up only being 8 million people. So how accessible do you want it to be when? Right now, to me, because I thought somebody would come up with like a really easy path, I never learned CAD, and I outsource it. So I have a whole group of people, and I'm just really good at working with them, and they're really good at CAD. And one of them's for medical, and the other one's for like more difficult stuff, and the other one's for more like organic shapes or cleaning up scans. And that's how I do it. And for me, it's not necessary to do that skill. And I do make products, right? I do have people that I know that I make products with, and we design stuff for big companies and all this. And it's okay because there is a person out there that's amazing at CAD or 3D modeling or design. And then you can make something much better, and you can just work together with that person. And that to me is a viable solution. I mean, I make products, but I don't make products every single. Well, I kind of print stuff often, but I don't make new products like every single day, So, but generally, there's people, and a lot of these people are like, you can, and they're all over the world, right? So you can find really talented people and work with them, and you can pay them quite well, and they'll be paid super well for where they are, as well, if they're in India or if they're in other places.
So essentially, what you're alluding to is kind of finding your own niche, right? That's what works for you and your product development cycle. And if you can kind of, like, if it was me, I have that sort of network of people like, hey, can you clean this scan up and send it over here to this guy? And I have it all in alignment, ready to go. I just want it like this, and then send me back, and I'm going to hit print. That sort of thing. I mean, I like that idea.
That to me is important, also because the technology is always evolving, and you're going to deal with different things. And I don't think you could learn the technology if you're really interested in it. But as a business practitioner, you have to be smart with your time. And if you don't have enough time, you should be seeing patients. That's what you should be doing. You should be on next to someone, finding out what their needs are and finding out what you can do better, and coming up with a solution. Now, if that solution is to design something better, right, and you have to make a novel device, okay, then I can understand that a really thorough knowledge of engineering and CAD and the hands-on approach is amazing. But if you're doing essentially the same thing over and over again, to me, I don't know, to learn AutoCAD for that is not exactly like the most exciting thing in the world. It doesn't differentiate you from anyone else.
Sure. Yeah, I mean, I think that's where, and that's what I love about our field, is that we have very, very creative people that have been able to traditionally manufacture things. And so if we can just turn the knob just a little bit for them and say, hey, we want you to be as creative or more creative and design the things that you've only dreamed of designing. And all you have to do is be able to communicate that to somebody, and that somebody is really good at making your napkin sketch idea, whatever, come to life. Then the outcomes that we're going to see is better and better. And then it's just going to spawn more creativity within the field. And to me, that's what's exciting.
That's all. And there's also other things where we can never replace the traditional craft. I mean, a last second adjustment kind of thing, right, or making something with your hands that is just going to make somebody a little bit more comfortable, that would take you hours with a 3D printer. That would take you hours with designing and 3D printing, compared to molding something really quickly or making something on the fly adjustments. They're always going to be faster. Right. And a lot of structures we can't do, smooth things we can't do, straight pin kind of things is stupid to 3D print that. There's like a ton of stuff that will never make sense. I mean, like you say, even if the whole workflow would be easier if it's all digital, you're still going to probably want to use a big metal pin that's been made conventionally,
Sure. Well, and I think to your point on that is, I think where the other thing that has kind of cooled our industry is that there's a lot of people that have tried to make product or software without the clinical input. So they try to almost like shove this down. Hey, you need this, but they don't understand the whole back end of what that means. Like, yes, I've created a product that is amazing, but that product is so much more expensive than what I'm going to get paid for it. I can't buy it. Yes, do I want it for my patients? Absolutely. But I cannot buy that, so I still have to stick with what I'm doing. It seems like there's a little bit of a disconnect. And I think it's getting better, though, where clinical feedback is requested. But to me, it's super important, because if you try to remove the clinical expert from it, I truly believe that you're doomed to fail right off the bat. But if you kind of bring us into the fold and give us a little bit of insight and tweaking to what may suit the needs that we have and the needs of our patients to fit within a framework of how we're going to get paid and what the workflow looks like, I think that's going to be a better way to approach changing our industry than giving us something that we don't need.
Yeah, totally, dude. Totally. I really like talking to you, Brent. I think this is a really nice first episode to get our feet wet in this.
And we didn't even touch the day in the life of.
Yeah, what we're going to do for the next episode is we're going to look at the day of the life of an orthotist and prosthetist. And that's just to give me a little bit more of an understanding to figure out, like, hey, what do you actually do day to day? Like, what do you do from the beginning of the day to the end? Because I have no idea. But I think now we got a little bit of kind of like, we kind of made our battle lines, if you will. We kind of like scoped out kind of like where we're headed and to call the whole territory. And then we do that. And then we also have to look for guests. Huh? We need to find guests.
It's not going to be a problem. Yeah. No? I mean, okay. Yeah, no, I probably have at least 20 people that want to do it,
Okay, perfect.
Yeah. Perfect, and then, from my side of things, and I saw that you liked the thing about the Linkster group that came and visited Raleigh through the French embassy or whatever. They had reached out and said, hey, can we meet? But the 3D printed silicone stuff, whether it's them or other people, like, I'd love to talk to some of those people that are into that. The people that are printing in the suspension, like the gel suspension type of thing.
Fresh. Oh.
That would be fun. And just to get their idea of like how it could apply. And I think that's where, like, some people in metals maybe of like, hey, do you ever see a time where, 3D printing anything in metal for our external prostheses or orthosis actually makes sense? The other thing, like, there's definitely some softwares that I'm interested in, some printing manufacturers, So I think it's wide open. But yeah, I would have no problem filling probably 20 to 30 people within the next couple of days if we needed it.
Awesome, dude. I'm looking forward to this. So, Brent, thank you for being here today.
Yes. Thank you, Joris. I love the conversation, love the insight, and I think this is going to be a fun journey.
Yeah, totally, dude. I agree with you. I hope so, too. I hope so as well. This is the Prosthetics and Orthotics podcast. My name is Joris Beals, and you were also with Brent Wright today. And thank you so much for listening. Yeah, we hope you continue to enjoy this journey with us.